Welcome to section 9.1, where we're going to be talking about null and alternative hypotheses. So let's do a little introduction here. Statisticians make statistical inferences about populations based on samples. That's what they do. One way we've done this already is by confidence intervals. And the next way we're going to do this is by hypothesis testing. And that's what we're going to start doing in this chapter. Let's do some examples. Let's say we read in the newspaper that the unemployment rate is 13%. We would need a way to test to see if this was true or not. Maybe we read that in 2014, women only earned 79% of what men earned working full time for a year. Another example of something we could test. And finally, in California, managed care company Kaiser Permanente, which employs over 300,000 people, said its employee vaccination rate spiked from 78% to 97% after the state declared healthcare workers needed to get vaccinated or submit to twice weekly COVID 19 testing. Another example of a statistic we could test with hypothesis testing. So this is why we want to learn how to do this. This is what we're going to be doing in chapter 9. We're going to set up two contradictory hypotheses, the null and the alternative. We're going to collect some sample data or be given sample data. We're going to determine the correct distribution for the hypothesis test. We're going to analyze our data samples and perform some calculations that either allow us to reject or accept the null hypothesis. And finally, we're going to make a decision and write a conclusion. Today, we're really just going to, in this video, we're really just going to focus on number one, setting up two contradictory hypotheses. The two contradictory hypotheses are going to be the null hypothesis, which is used H subscript 0. 0 is another word for null. And this is a statement that the value of the population parameter is the same as a claimed value. And that means no change, null. That's why we say null. The alternative hypothesis is H with a subscript of A. And this is a statement that will contradict the null hypothesis. Let's look at some important facts about these. In the first column is things about the null hypothesis. You will use a symbol equal. It might use a symbol greater than or equal to. It might use a symbol less than or equal to. If the null hypothesis is equal, then the alternative hypothesis would be not equal. Or if it might be greater than or it might be less than, but these would go together. If the null hypothesis was greater than or equal to, then the alternative hypothesis would be less than or equal to, and that would be a better chart. So let's pretend that these guys are switched. Oops. So if the null hypothesis is greater than or equal to, the alternative hypothesis would be less than. And if the null hypothesis is less than or equal to, the alternative hypothesis would be greater than. Remember, the null hypothesis always has an equal sign in it, always has an equal sign. And the alternative hypothesis never has an equal sign. One thing we should note is sometimes the researchers will always use an equal sign in the null hypothesis. They won't use like a greater than or equal to or a less than or equal to. That's just something to be aware of that some researchers do. Let's look at an example. The average height of 8th graders is 66 inches. State the null and alternative hypotheses. Well, the statement is that the average height is 66 inches. That's an equal to statement. So my null hypothesis is that the average height, mu, the average height of the population, is 66 inches. The alternative to that would be that it's not 66 inches. So there's my null hypothesis and my alternative hypothesis. And this one is about an average, so that's why I use the parameter of population mean. Here's another example. You are testing that the mean speed of your cable internet connection is more than 3 megabytes per second. State the null and alternative hypothesis. Well, the statement says more than 3. More than 3 is greater than 3. We can't put that into a null hypothesis because a null hypothesis always uses the equal sign. So this one must be the alternative hypothesis. Mu is greater than 3. That means that the null hypothesis has to contradict it. To contradict greater than 3, it would be less than or equal to 3. One more, and then you guys can try some. A sociologist claims the probability that a person picked at random in Times Square in New York City is visiting the area is 0.83. You want to test to see if this claim is correct. State the null and alternative hypotheses. All right, so the statement is that a probability that a person picked at random, so this is a proportion, is equal to 0.83. And remember, we have is. So that's going to be our null hypothesis. The population proportion, P, is equal to 0.83. So the alternative hypothesis will be that P is not 0.83. All right, here's some for you guys to try. Why don't you go ahead, read these, and then we'll come back and we'll try and state, sorry, read the examples, state the null and alternative hypothesis, pause the video until you finish it, and then come back and we'll go over them together. All right, let's try the first one together. The mean entry-level salary of an employee at a company is $58,000. You believe it is higher for IT professionals in the company. State the null and alternative hypotheses. Well, it says the mean, so we know it's a population mean, entry-level salary is equal to 58,000. So that would be, whoops, I just jumped ahead. Well, I guess we'll just go here. That would be mu equals 58,000. The alternative hypothesis to 58,000 would be not 58,000. Even though we believe it is higher for IT professionals, we needed to contradict the null hypothesis. So we can't be greater than, we needed to contradict. So it's going to be not equal to 58,000. Okay, the second one says in a population of fish, approximately 42% are female. This is a proportion, so we're going to use the parameter P. A test is conducted to see if, in fact, the proportion is less. State the null and alternative hypothesis. All right. So in this one, approximately 42% are female. So that's our null hypothesis. The probability, the proportion is equal to 0.42. The alternative hypothesis will be that it is less, 0.42. All right, that's it for this section. And please watch the video for 9.2.